Hello students, welcome to the class of digital signal processing. We have studied discrete Fourier transform, the starting part of it, and we also solved a question how to take out direct DFT, direct discrete Fourier transform. So the sequence xn will be given to us and we can find out x of k. Now today first we will start with how to find the IDFT directly without using any algorithm. So let's get started. The question will be in this manner. Find IDFT of the following. So the question will be of this format x of k, because we have to find out the inverse discrete Fourier transform. So it is x of k. The values given here are 1 minus j2 minus 1 and 1 plus j2. So what we have studied till now is the formulas for IDFT and DFT. So once let us revise that part of it so that you are not having any confusion regarding the sequence which is given here. That is the Fourier values are given. The value in the omega domain is given to us. Let us see. So what happens if you are given a discrete time sequence xn? If you use the DFT, discrete Fourier transform, it gets transformed to xk. And for if the xk is given to us by using the inverse discrete Fourier transform, it gets transformed to x of n. Now, the formula for x of k is, how you take out this x of k is xn, n is equals to 0 to capital N minus 1, e to the power minus j 2 pi k n by n. Okay. For this xn, when you're finding the inverse discrete Fourier transform, the formula is 1 by n is equals to 0 to capital N minus 1. Sorry, here you are having xk, so the range will be from k, right? Whichever is given to you. Here n was given, so here the range is from n is equals to 0 to n minus 1. Here k is given, so the range here will be k equals to 0 to n minus 1. X of k e to the power j 2 pi k small n by capital N. So just for revision, I'm once again telling that we started with DTFS, then we went on to DTFT. Now we are doing DFT, and the last thing that we will be doing will be FFT. So this is discrete time Fourier series, this is discrete time Fourier transform, this is discrete Fourier transform, and this is fast Fourier transform. So here in all these cases, my signal, that is x of n, is a discrete time sequence. It is not x of t, it is x of n. Now in this case, it is periodic and you are taking out the harmonics. In this case, it is non-periodic and you are taking out the Fourier transform. In this case, it is periodic and also finite. But in this case, it was periodic but not finite. In case of DFT, it is periodic and finite. For fast Fourier transform, it is basically an algorithm which is reducing the computational time for DFT by using the property of the Twiddle factor. Or you can say the property of this e to the power minus j 2 pi by capital N. This is my Twiddle factor. So we will discuss on this a bit later. Okay, now let us find out the IDFT of this sequence. So what is What is capital N given to us? Capital N is your number, total number of sequence, or you can say the time period in this case, right? So how many are given to us? Xk was given to us as 1, comma 1 minus J2, comma minus 1, comma 1 plus J2. So it is 0. This is the position of 0, 1, 2, and 3. So the total number of samples here are 4. Okay. Now, what we are going to do is first we will write the formula again. Xn is equal to 1 by n summation k is equals to 0 to n minus 1. Xk, just keep in mind what you are finding out. E to the power j 2 pi k n by capital N. So first we will take out this part, that is e to the power j 2 pi by n. So that because it is going to remain common for all, that's why first we are going to take it out. E to the power j 2 pi by 4. So this is equal to e to the power j pi by 2. Now this is equal to cos pi by 2 plus j sin pi by 2. You know the value of cos pi by 2 is 0 and sin pi by 2 is 1. So the answer here is coming to be j. Okay. So the value of e to the power j. Okay. Actually, what we will do is we will take it till this point, because after we will put these two things over here, that time it is going to change, right? So we are going to take this part. Okay, let us now start x of 0. First, for small n is equal to 0. That means x 0. Now 1 by n, k is going to range from 0 to capital N minus 1. Capital N is 4, so it is going till 3. X of k, now here it is going to be e to the power j 2 pi by capital N into k into small n. Now small n is 0 for us. So for whatever values you take, so now first one I am explaining completely. So whatever values of k you take, the n is going to be 0, and hence what is going to happen is that this full thing over here is going to become 1. So basically here it is going to be only the value of k is going to change, x0, x1, x2, x3. Now these values are already given in the question to us. So 1 by 4, 1 plus 1 minus j2 minus 1 plus 1 plus j2. So what is the value that you are getting? 1 by 2. Now when we will find out x1, now for x1, that is for small n is equals to 1. So x1 you are finding 1 by n, capital N here. First I'll write the full formula. K equals to 0 to n minus 1. Xk e to the power minus j 2 pi by capital N into k into n. Okay. Now here the capital N value is 4. K is going to go from 0 to 3. The xk is changing for us. Now, the most important thing, here I have written a small thing wrong. This is plus because we are taking out inverse discrete Fourier transform. Now for us, this part, we have got it as what? J. Okay. So, okay, first I'll show you. If you have got this as e to the power j 2 pi by 4, if I take the value of k equals to 1, and if I take the value of n equals to 1, so this is going to be how much? E to the power j pi by 2. Now this is going to come j. If you take e to the power j 2 pi by 4 into k if you are taking as 2 and n is 1, that time it is going to come e to the power j pi by 2 into 2. This is going to be e to the power j pi. Now e to the power j pi will be what? Cos pi plus j sin pi. Now see, over here in the top, we have taken out this value as e to the power j pi by 2, and first finally when we have simplified it, it was only j. Now if I take this j and raise it to the power of 2, how much will I get is -1. And in this case, cos pi plus j sin pi, if you write, again, this way also you're getting the value -1. So why I wrote it in this manner was to show you that if you first take out the value of this twiddle factor, what I did over here, this one here, you took out the value of twiddle factor, and after that you will raise it to the power k to the k into n. Whatever value of k you are having, whatever value of n, that you will put, and accordingly this j is going to, the final value is going to change. So that we will use here. So let me write it down here. Okay, for this one, e to the power j 2 pi by 4, it is becoming j. We know it right now. Now this is k into small n. Small n is, we are doing this for 1. So this is 1 over here. After that, now we just need to change the value of k. So 1 by 4. First one will be 0. And if k is 0, it is going to be, full thing is going to be 1. Now next one is x1 j to the power 1. Then it is x2 j square. Then x3 j q. That's it. So the chances of making mistakes becomes less. If you write it, find out the twiddle factor beforehand. So this value of x of 0 was 1. Then for x of 1, the value is 1 minus j2. If you multiply it, then j minus 2j square, right? Plus the value of x2 was -1, and this is also -1, so it is going to become +1. x3 was 1 plus j2, and that is multiplied with j square is -1 and this, so minus j. So just go on. This is going to be 1 by 4, 1 plus j minus plus 2 plus 1 minus j and minus j cube. Minus j cube means j square is -1, so it becomes plus j. So this cancels. You have over here, the value is given to be 1.5, but what we are getting is 3 plus j by 4. So let's once see it once more. This one was x1 was 1 minus j2. 1 minus j2, if you multiply with j, it is going to be j minus j square into 2. So this j square is -1. That will make it +2 over here. So j plus 2. Then x2 is my -1. -1 and j square is -1. So it is +1. x3 is 1 plus j2 and this is j cube. So j cube is made of j square into j. So this is going to become -j. Now this is -j. This is j square into 2. Sorry, this was 2j. So here was the mistake. Let us write it once more. So this is what? 1 by 4, 1 plus j plus 2 plus 1 minus j minus 2j square. This is minus j and this is j 2j into minus j. So j square is going to become -1. So finally it will be +2. So the value of j gets cancelled with -j. And what you have here is 2 plus 2, 4, 1, 5, 1, 6 by 4. That is 3 by 2 equals to 1.5. Same way, let us take out x2. X2 means over here the signal at n is equal to 2 by doing the inverse discrete Fourier transform. So 1 by 4 k equals to 0 to n minus 1 x of k e to the power j2 pi k n by capital N. Okay. Now, so we will be writing x2 1 by 4. We will once more write it k equals to 0 to 3. Now this is xk. This is going to be j into what? K is going to change, so we'll put k, but n is 2, so we'll write 2k. Fine. Now we will write in the format with the values given. 1 by 4 x0 plus x1 into j to the power 2 into 1. So that will be j to the power 2 plus x2 j into 2 in j to the power 2 into 2, that is j4. Now x3 j to the power, now this k value is going to become how much? The k value is becoming 3, so 3 into 2, that will make it 6. Now the value of x of 0, capital X of 0 was given in the equation, in the question to be 1. Then x1 was given 1 minus j2. This is multiplied with j square, that is minus 1. x2 was given minus 1. This is multiplied with j to the power 4. J to the power 4 means j square into j square. That means minus 1 into minus 1. That will be plus 1. x3 was given as 1 plus j2. Now this j to the power 6 means j square to the power 3. Right? So this is minus 1 to the power 3. That will make it minus 1. So this is minus 1. Now 1 by 4. 1 minus 1 plus 2j minus 1 minus 1 minus 2j. Minus 2j plus 2j and plus 1 minus 1. So this is minus 2 by 4. That is minus 0.5. Now same way, let's take out the last one, that is x3. The value at x3. So write the formula once again. 1 by n k equals to 0 to capital N minus 1 xk e to the power j2 pi k n by capital N. Fine. So now 1 by n was for me, capital N was 4. Now k is equal to 0 to 3 xk. Now e to the power j2 pi by 4 will be what? E to the power j pi by 2, that was j for us. Now j is raised to the power of k into n. For our case, k will be changing, n is fixed at 3. Now 1 by 4, x0 was 1. So I'll write it first, x0, then x1 into j3 raised to the power 3, x2. Now k value will be 2, so j will be j to the power 6. Now k value is 3, so j will be j to the power 9. Now x0, capital X0, the value is given in the question is 1. For this one, it is given 1 minus j2, and j square is minus 1, so j cube will be minus j. x2 is given 1. j6 is what? j6 is again same thing, j square to the power 3 means minus 1 to the power 3, that will be minus 1 itself. x3 is 1 plus j2 and this is given as j to the power 9. So j to the power 9 is how much? Let us take it out. You can write this j to the power 9 as j square to the power 3, right, into j to the power 3. Why? This will become 6 plus 3, 9. So you know the value of this is -1, and you know the value of this is what? Minus j. So together this becomes plus j. So here it is plus j. Now 1 by 4, 1 minus j plus 2j minus 1 plus j plus 2j square, that will be minus 2. Now plus j and minus j gets cancelled. Plus 1 and minus 1 gets cancelled. What you have is 2j minus 2 by 4. So take 2 outside. So 1 by 2 j minus 1. So the value, let me once check, it is coming out minus 0.5. So this j should cancel over here. Let us just once again see it. So the value of xj was minus 2j, 1 minus 2j over here, and minus j cube is becoming j square into j, so minus j. Now 1 plus minus j, this is plus 2j square. Sorry, I took this one as 1, I think. So this is 2j square. So this is going to become over here minus 2, sorry. So this is going to be 1 by 4. Now these two are getting cancelled, but this is minus 1. So minus 1 into 2. Minus 1 into 2, that is minus 2. And this is again minus 2. So this is coming out to be minus 1. Let us once again see. There is some issue in this part, in the calculation over here. So 1, x0 was 1. 1 minus j2 into minus j. Then it is minus 1 over here. Sorry. This is minus 1. So this is okay. 1 minus j plus 2j square. This is becoming plus 1. Let us do it once more from this point. So be very careful while doing these questions because it is very calculative. Actually, you have to be concentrated, otherwise there can be silly mistakes. Okay, let us now go ahead and do it. So this is 1 by 4. Now this is 1. Next is minus j plus 2j square plus 2j square. That means 2 into minus 1. So 2 into minus 1 will be minus 2. Then it is plus 1. Then plus j plus 2j square. That will be minus 2. So plus j and minus j is getting cancelled. 1 plus 1 is 2 and minus 2 will be cancelled. So minus 2 by 4, and that is minus 1 by 2, and that is minus 0.5. So finally, the value of xn that we are getting is, the value of xn that we will be getting is how much? So it will be for 0, 1, 2, and 3, small 0, 1, 2, and 3. So let us see the values what we have got. X of 0, x of 1, x of 2, and x of 3. So x of 3 from here I'm writing it minus 0.5. Let us search for x2. X2 value given here is minus 0.5 again. This is minus 0.5. So this x2 is also minus 0.5. Now let us search for one x0 and x1. So x0 also it's 0.5 it seems. x1 is 1.5, x1 is 1.5 and x0 is 0.5. Okay, so x0 is 0.5 and x1 is 1.5. And from that, we come to the end of the IDFT, how to find out the IDFT if you have been given x of k. So that means you are finding out x of n where you have when you have been given x of k. So this will be the value. Write them together as in this manner. 0.5, 1.5, minus 0.5 and minus 0.5. Okay, thank you everyone. So next class we will be doing the property of DFT and then we will start with FFT. Thank you.